So yeah, there is a file. So let's use this text.txt. Only I am not giving the whole folder name. I'm just giving one file so that it runs faster. I don't know what is lying in another. So let's try to run it. So this will now trigger a MapReduce code, and it will do all the things which we were discussing in last two classes. It will communicate with uh, okay, so as I told you last time, if the output directory is existing, it will give you an error because it assume that there's some data lying over there. It don't want to delete it, and it cannot append to it. So you have to delete the directory if output directory is existing. Hadoop fs minus rm minus r and the directory.
So if you had input instead of one file, you would have given input as the directory.
So input
it would have taken all the files from that directory.
Yeah,
right?
all the files. It would have taken a lot of time to run.
No, but in the output, it would have basically read through all the files and given one single combined answer.
No, not one single number based on the number of reducers created. So each reducer one file.
Correct. Yeah. Okay.
So it's started a job. I've got the job ID from your job tracker, and this is a URL where I can track this job. So one more thing. When you will open this URL, you will not be able to browse to it because your machine is running practically on 127.0.0.1. So add this entry sandbox.hotandworks.com to your what do you call it, host file.
Host file.
So otherwise you have to change it again and again to 127.0.0.1. And वो कई सारे बात at the backend में ना वो 3-4 URL resolve करके इस URL पे आता है practically.
So can you show your putty again?
Yeah, I'm showing it to you. So here you can track the job. The job is running. It has one mappers right now, which is starting up and things like that. Now we can go inside the job and clicking on it. So it ran. So there is a little delay over here. So here you can see the mapper started, the mapper code started, the reducer code started, the job ID successfully completed. It also gives you different statistics about the job, the files, number of bytes read and things like that, job counters, MapReduce framework, number of records and all those things, reduce shuffle bytes, input size, and number of things, and it has finally done the things. So if you look at this output directory, Hadoop fs minus ls and the output. So practically, okay, let's look at this directory first. So only one reducer, small file. So Hadoop fs minus cat. So see all your word and the corresponding counts. So in that file, the file was, if we open that file, so that file had some contains some words and all the words out of that file and the corresponding counts of them are there. And now you can see the words are sorted, and I hope you understand the reason.
Can we just see the input file once?
Yeah. So there is the input file.
So in this particular scenario, okay. In this particular scenario, like it is the new line character, right? It will like how for every word it is there. No, I'm just asking, like in the program, like we have the new line character as like one of the like separators, or like what else, like what we have here, like in the code. Can you show the code once? Like what is that?
So what we did is we use a string tokenizer that does nothing but tokenize the line.
Yeah,
Each word, basically space is a tokenizer. So each word becomes a new token.
yeah. Okay. String tokenizer.
Okay,
Okay.
sure. So just give me a minute. Let me open the PPT. So are you people using somewhere Hadoop or any of your projects using it, or just you're planning to use it, or just
No, this is my, at least for me, I want to learn Hadoop. I don't have anything which is going on, but
okay?
I of course I work on architecture of BI projects as well as Oracle related projects, right? So
Acha, BI.
Hadoop is something which I'm trying to learn.
Okay. So you are using
Yeah,
Oracle
same.
only, or Oracle Exadata, or things like that also?
Exadata I got experience, but I'm not using it at this time. But
Some of the things are similar to Exadata over here.
oh,
So there also you can try out, but the beauty over here is that the data is replicated. So there's
correct.
no write or read contingencies like Exadata might give you in high mode.
Yeah, but I worked with MongoDB and all where that replication concept is there.
So these things we have already discussed. Lookout reader, mappers. Uh, I think we discussed a record reader, right? Creating the mapper.
Mm, I
I
record re
No, we stopped at the recorder, I believe.
Yeah, recorded, right? So
Yeah.
I will just quickly browse through. That will give you a quick. So what we did with the diagram. Yeah. So there's an input format, that is the input file format, which basically reads the data for you. The default one is text input file format, and there's a record reader associated to input file format. So that record reader basically reads a record by record from your input split. Input split is nothing but a logical division of your data. So the default ones are there, and also there are some implementation for input file format which we discussed over here. The text input format is the default one. Key value text input format, where you can define a key and the value out of your data based on a separator which is defined or which is configurable. Then we looked at the sequence file and the n-line, where n-line becomes your record rather than sequence. Then the record reader. So there is, as I told you, record reader associated to with each input file format. There is a separate record reader associated to. So and you can create your own also. So the text one is associated to text one, and the line one is associated to line one, and the key value one. Then creating the mapper. So we looked at the mapper class. Mapper class contained so mapper class contains basically has to extend the mapper, and it has to tell what is the input key and value and what is the output key and value types, and same has to be there. So this is the input key and value type, and what is output data from here need to match this thing, and it has to have a function called map. So we already discussed keys has to be writable, comparable, and the values has to be writable. So these are some default mappers which are already implemented, and you can directly use them. So rather than creating this map class, I could have used these mappers in my job configuration. So where I can just say my mapper, rather than using this one which I have created, I can directly use this default one which are already created for us in the Hadoop world. So if you want to do these kind of functionalities, you can use some of the already created mappers. So like identity mapper, which do nothing but it just embeds the key and value which has been input to this. So it practically does nothing. Inverse mapper, as the name suggests, it inverts the keys and value. So value will become key and the key will become value in the output. Regex will basically match your expression based on the regular expression defined to this mapper and will print a match and the count. And similarly, token mapper will basically count the tokens. Sorry. So similar to that.
We could have used this.
Yeah.
We could have used this token count mapper, right?
Yeah, definitely. We can try it out. Reducer. So as a mapper, you have the reducer. So this is the input to the reducer and practically the output of the mapper. And there is the output which has been which would be going to a register part. So similar to mapper, reducer has a reduce function which takes the key emitted out of the mapper and the value, but the value is iterable because I told you though everything is grouped into an array kind of thing in the shortened subspace. So that thing and the output, this is the kind of output which the reducer will be emitting up, and this will be going to your SGFS part. And here you can see the output which came. You can see the keys and values are separated by tab, and I hope you understand because the default one is tab, so keys and values are separated by tab. So this key was basically the word and the count, so they are separated by tab. I could have used some other reducer to change the separator. So similar to your input, the reducer output also works on the same thing. Output instead of input format, there is an output format class, and there is a record writer which is associated to an output format class. So the default one is taken care when we emitted the data, and the default one they use a separator as tab. So okay, before going to that part, let's look at some of the useful reducers. So there's something called identity reducer which do nothing but the input and output are just dumped about what they are. And there's a long sum reducer which basically counts the values for a given key. So we could have used this also in our reducer. So similar to input formats, there is a text output format class, which is a default one, which is taken care of over here, and that's the reason keys and values are separated by slash tab. If you wanted to separate them by comma or something, we could have changed the separator, or we could have used some other class. So sequence and file output format class, we'll talk about sequence files, then I'll discuss about this thing. Null output is nothing but if you want to suppress the output of the reducer due to some particular scenario, you can use this class. Anything which you want to ask? I've gone a little quick, but these are the things which you discussed yesterday, and just similar to those things.
Can you show in the program where that output format is?
Yeah, so let me show you a few other programs. So let's.
So in our program, we have.
Yeah, so our program we are using the we have not defined the output format. So this is the one which has been taken used, text output format, which will separate by slash tab only.
That is the default.
Yeah, that is the default.
Okay.
So let's look at few other programs. So let's look at creating an input format. So what is this one? Okay, so here what I'm doing is I have used key value text input format, and I've defined what is a separator for me. So separator is comma for me. So anything before comma will become my key, and anything after comma will become my value. So let's look at this input class.
This for the mapper, right?
This is for the mapper. Yes, right now I'm showing you for the mapper. Yes.
But then if there are multiple entries on one line, so
You
can
can
you
you can
have
no, you can define the separator only one separator because at a time only one thing can become a key.
no, but you cannot have key, comma, value, space key, comma, value, space key, comma, value types.
नहीं फिर आपको yeah you can have that practically but in that case you have to define the separator for a record so you have to change the separator for your record also.
Okay.
So
So basically what you're saying is in your example, it is assumed that every new line will have
yes,
only key, comma, value.
yes. So in this example, new line one line is a record.
Okay. Okay.
It directly exists. Okay, just give me a minute. Let me check this is exactly existing or not. Just give me a minute. So see that program ran and it shows you number of reducers, number of mapper. Here you can go and look at the logs. So I'll show you all those things later on. So are the logs related to your job. You can see the logs related to your mapper and reducer which they've printed out. So this, well, I'll tell you all these things when we look at the yarn. So for your question, I'll show you one more example. Give me a minute. That will make it more, make more sense. But just let me cross check if this file gets use a new DP map reduce. New DP map reduce. Key value. Key value. Input.
You got a baby at home?
Yeah, looks like she waked up.
That's okay.
Yeah. Okay, so here's the file. So instead of map reduce,
Input.
I'll just use input rather than map reduce. Okay. Let's open that file also by the time it's running. So this is a simple file which where we have 4-5 lines. Hello, comma key value ABC, comma text, third, comma value, fourth, comma fifth, and ABC, comma 6. And let's look at the program what we are doing over here. So we have the mapper and reducer. So mapper is doing nothing but it's just emitting what it's getting. And the logic for the reader is saying comma is a separator for my key and value. So this thing will become your key and this thing will become your value. In the reducer part, okay. In the reducer part again, I'm not doing anything. I'm just emitting what I'm getting, nothing else. But for all the values, I'm running a for loop so that each value is printed one by one. So can you tell me what would be the output? Tell me the exact output. What do you think would be? I'm pinging this on the chat.
It will be ABC 6 ABC text, then fourth, fifth, then hello, and then third value.
Yeah.
Allow one.
And the output directly are not deleted. and the values would be separated by tab.
Yes.
So let it run, and by the time, let me open some other program. Let me show
So
you.
in which application would you use really the identity mapper?
Uh, let's say I have a file in text format, but Hadoop supports many other file formats.
Hmm.
So all I want to do is I just want to convert that file format to some other file format which could make my queries faster, like RC file formats, ORC file format. We will look into those things. So I can just emit out and just change the file format. I'm just giving you a weird example. Um, or I just want to do something on the mapper side. I don't want to do anything on the reducer side. Or I just want to do something on the reducer side, like I have some operation of order by kind of thing or something. I just want a reducer. I don't want a mapper. So some rare cases you can do that. It could be okay, fine. So let's look at the output. So right.
Mm-hmm.
Okay, let's look at some other things. Input multi-write input format. Okay, let's look at this input format example. So there's the implementation of record reader, and this is your this is your main program. Okay. So let's look at this file first. What we are trying to do. Yeah, the file property here. Produce access log. Okay, just give me a minute. Let me upload this file. Give me a minute. So to just search where this file is lying on my PC also. Windows is one of the worst software I have seen. Just give it 2 minutes. Actually, there's a new laptop where I think some of the things are not configured. So while the time is going up, let's look at this program. So what we have is an access log that is nothing but a kind of clickstream logs. So what we are doing is we have created our own file input format. So and we are using is something like this. So we are creating our own file input format, that is log file input format, and that is extending the file input format of the Hadoop. And for that file input format, we have to give what is the record reader what we want. So I've created our own record reader, and we are returning the instance of that record reader. So in this record reader, what we are doing is, so therefore there are a few implementation of what is required for some other things, but this is the main thing which is required for us. That is the next key value. So there is a function which basically returns the next key and value to your mapper function. So mapper, this next key and value which is returned by this function is basically sent to your mapper function, map function. So what we have done is we have used a regex operation to separate the different things available in the clickstream log. So the file is downloading. Just give me a minute. So here what we did is we separated out different things from the file. So what we said is based on this regex, so we have matched the IP address, the timestamp, the request, the status, the bytes, and then we have set into a single object, and we have used that object. So in the mapper class, what we are getting is so in the mapper you can see I'm getting an object, and I am basically I'm getting a log writable as an object as a value, and from that value I can easily get the IP address and the response size. So what I did is the thing which you were asking, if there are multiple things I want to use them, but your question was little separate, so you can also achieve that. But I'm showing a similar example where there are a lot of things in my file and I've converted it to objects. So in the mapper class I can easily get the corresponding values what I want.
This is a bit too fast for me.
Okay, I'll again repeat it. Not one.
Miraj, like if you can just take an Excel sheet and just show the example of the file and then walk through the code, like that will be easy. You don't need to then run it.
Yeah, I'm just uploading the file. Give me 2 more minutes. It's just getting uploaded. Just give me 2 more minutes. I figured out where the file is lying. I'm just trying to upload it.
Okay, and also like this file is there in the code base that you have shared with us.
अच्छा हाँ ये उसके अंदर हाँ सब कुछ पड़ा हुआ है वहाँ.
Okay.
Whatever is required to run them is lying over there. So yeah, it's copied over here. So this is a file. Okay, clickstream logs.
Okay.
ठीक है. IP address, what time, the kind of request, get, put, the URL which was hit, the response 200, 400 kind of thing, number of byte transfer. So this is a normal clickstream log on any server if you look at. Okay. So we have to process this clickstream log. So so this is lying over here. I just delete this guy. So that will be lying in a MapReduce folder in the data. Okay. So what we did is we created our own input file format which can process this data prior it's being sent to the mapper, so that I can get these individual entities in the mapper class. So what we did is we created an object called log writable which has all these things: user IP, request, time response, grants, and we are setting up, or we are initializing this object from the input file format and sending it to the mapper. And how we initialize it? By creating our own self input file format. And what we did for creating that thing is we created our own input file format, and inside that we did nothing but we created a record reader for us, and we use the default file input format which reads the record line by line. But how to pass those records? We use our own record reader. So in the record reader, what I did is I have used a normal regex operation to split these values into different entities, and those entities based on the regex matching I have assigned to the things and set it to a object which I've shown to you, that is a log writable object. And now in the mapper, my key, my value becomes log writable because I'm returning it over here. So in my mapper, mapper. So in the mapper class, I'm getting the key as an object and the value as a log writable. So I'm ignoring the key. I don't want that key. I'm just considering my value. So I'm sending these values to my reducer by creating a key out of what I wanted to do. Now does it make sense? What we are trying to do, this is an example that I'll explain. So there are a few other things which we are trying to do. So let's say the problem statement is, okay, so find out the response size returned to each IP. So this is a problem statement, pretty simple problem statement. So this is the IP address and this is a response size returned. So this IP address could have been hit n number of times. This IP address would have requested n number of times. So we have to figure out the total responses returned to each IP address, and we want to look at that statistic. We want to draw that so that we can figure out who are the users who are frequent visitors to our website or things like that. So what we did is we created our own input file format and the corresponding record reader. From the record reader, we separated these things. So we have now IP address in a separate entity, timestamp and protocol, URL hit, and all those things are separate entities, and the bytes as well. So in the mapper class, what I did is I have created IP address as a key and the response size as a value. And the reducer, now I know I will get the IP address as a key and all the response size written to that IP address as an iterable. So I'll just sum them out and print them out. Make sense?
Yep.
So let's try to run it. I chose similar few other examples. So now the file is lying over here. Now it will run. Before that, let me delete the output directory.
So instead of 1, you actually took the last value of the last token in that row, in that particular line, every line.
Sorry, where? What do you think?
Instead of, in our first example, we had always said 1, right?
Yes. So their value was 1 because the count was 1 for that word.
Correct. So instead of that, you took the last token from every
so
line.
that is the bytes. These are the bytes. So I just want the total bytes transferred to an IP address.
Yeah.
So if we run it, so see number of splits is 1 because the file is small.
Miraj, like, isn't it not a little slow?
Yeah, single machine पे चल रहा है, and I told you there's a small file. So practically on a small file it will run small only because the overhead or the bookkeeping activities or job tracker, task tracker or similar things need to do are pretty high as compared to data processing. But
Okay.
when you are really running on petabytes of data and compare it with your relational word or any other thing, then you will feel the difference. The index which was taking 24 hours on our Oracle table to be created up for a 20 GB or 1 petabyte table would be created in less than 20 minutes or 15 minutes based on the cluster configuration.
Okay.
So it's not for your select star from a table and then just return the table. वो यहाँ नहीं होता. वो time लेगा 1-2 minute. Select star from a table also. But when you are really running out of petabytes of the data, and then you will see the difference.
In the log, it talked about yarn.
Yeah. So that's what I said. That is 2.x architecture. What we looked at till now is 1.x architecture. I'll tell you there's a lot of not lot of, but there are some changes in the architecture. How there's nothing called job track and task track and yarn architecture. There's an application manager and resource manager. So that's the reason over
Okay.
here in this UI also now. So over UI. So see the different IP address and the corresponding bytes transfer. Okay. So if you look at this tracking URL, so here also you will see this, it will show you those things. Application master. So rather than job tracker, there's something called application master and similar things. So we'll talk about those things in yarn.
Okay.
Okay. So
Yeah. There is a new architecture, like, is like an improved architecture
yes,
than the
yes,
one you want of.
yes.
Can you show me the output of that file?
Yeah, that's what
Output
I
file?
showed right now.
But then everywhere it is not. Okay, am I seeing something wrong? Go scroll. Yeah, hold on. Why we are not seeing the IP addresses now?
So there might
That is
have
because
been
the
that
log
the
file
log file
format
does
is
not
not
contain
correct.
that is somewhere is IP address, somewhere it's URLs.
Okay. So it's a data issue rather than.
That's the data. That depends on just click string data. So multi-value table. I'll not go that deeper.
But if I had to write a MapReduce program, basically, essentially, I had to know Java.
Yeah, so that's why reason I'm not going into all these deeper programs. I'm just showing you few other examples. If I'm just looking at if anything else will make sense to you. Practically, you can do all these things from Harvard paper somewhere. So don't worry about these things. But I just want, so if you have an idea what is happening in this world, so the same thing will happen because Hive at the backend will trigger a MapReduce only. So there, if you understand there's an input file format or text input format or file format which is used to read the data, you can easily think of कि मेरे को क्या change करना पड़ेगा कि मैं data को डालूं या क्या मैं change करूं. So you just understand the concept. Okay, so this is
So Hive and all, like, they're like kind of your tools like where you can prepare this map producers.
sorry.
Like so Hive and all, like, are the tools kind of thing like where you can prepare this map producer for program.
No, they will
Like,
automatically do for you. You have to just type a command, select start from table XYZ, where XYZ, order by XYZ.
okay, so that way,
Every
like, it will program the like whatever is the map
every
producer.
everything whatsoever complex MapReduce is required for that, it will do for you. You will not see, you will not able. If you were not aware of there's something called MapReduce, you would have not seen that thing out.
Okay.
So in the real industry where Hadoop is being used, are most of the implementations not using MapReduce?
Yes. So if I say my personal experience, the projects which I've implemented till now, the 95% plus code is in high work only.
Oh, okay. Means it's good to know. Means understanding becomes much better.
Yeah,
So
but if you don't understand this thing, the concept क्या चल रहा है backend में, you can't optimize your
no, no,
hiring
I'm
thing.
understanding. I'm understanding this. The only thing is, if I have to write a new
No,
program, then
not
it
worry
becomes
about
a
it.
problem.
So
I can understand this.
don't write it. That's what I'm saying. Don't write it, but just understand these things, the concepts things. That's all.
Oh, okay, 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 fine.
So here what I'm saying is find the number of hits received by each URL, and the input file for this program is uh, weblog, weblog, weblog. The weblog line over there. Search again this weblog also now. I don't have this file right now. I don't have this input file. Wait, we'll skip this part. Somewhere it would be lying, but and Windows search is not working properly. So I'll not go into this thing. So here also we are doing the similar thing. So what we are doing is we have a regex. We have created regex based on the input data. So this is again a data similar to your this thing only weblogs. So the data was similar, but there's little difference in the data file. So the regex is little different. So data is almost similar, but the regex is little different. So what is our proposed statement? Find the number of hits received by each URL. So what we are doing is in the mapper, so in the mapper class, so by basically we read the data in a simple by your simple normal input file format, and in the mapper class we just ignored the key, and for the value we have just figured out the corresponding match for us, and we have used that as a URL and one as a count. So this will give you the URL and the corresponding count, and on the reducer side you can just count these ones and you can get the number of hits by each URL or by each IP address basically, or by each user, or if it's weblogs for your website, so to each for your URL. So it's almost similar file, but this regex will not work I think on this file, so I can't run it. It will give an error. So similarly, you have to just think your basically what I just wanted to tell you is you have to think your problem statement in key and value pair, and you can definitely achieve those things. All you have to do is just figure out how you can divide your data or over basically can divide and rule the things with key and value pair.
But from what I'm getting, though we are saying non-structured data, when you are defining your input means for the mapper, when you are defining the format of the row, you are defining some kind of a structure, right?
So if you have to process unstructured data, you are looking at some structured out of that unstructured data, right? If you have to, so you have to find out some stats out of your data. You have to find out some stats out of your data. So there's some structure which you found out of your unstructured data. Although the data is whole totally unstructured, but there's something in your data which you are really looking for. So let's say I have server logs. Out of server logs, what I want is number of errors coming into my file. So what I'll do is I'll just filter out on the mapper side if there's an error in this line. If there's an error in this line, I'll just print that line and I will do a count. So
Yeah.
although the data is unstructured, but my problem statement is I want to just figure out key how many times user. So similar is this log also. I have to figure out how many times users are bouncing back from my website. So a bouncing back means यहाँ पे 400 या 404 error आ रहा है, 404 or या 404. So although the data is unstructured और यहाँ पे बीच में different log files भी हो सकती हैं and number of things else also happen. But I have to figure out कि इस regex पे 400 is coming up, then only that line makes sense to me. Otherwise, I'll eat that. I'll basically ignore those lines. And
No, but that same thing is there in structured databases also. The only thing which I see unstructured here is the length of each column. It could be really variable.
not only that thing, but let's say my data is not like this, but my data is now what it will do. But in MapReduce, I'm not able to process this line. I'll just ignore it because I know this is the line where I have not got charts as an error.
No, that understand. But then when you really you define the structure of a file, particular row, you are giving the regular expression, right?
So in this example, I've used a regular expression, but there could have been the case, see, I just want to figure out the errors. So and there's no regular expression also. Let's say there's no regular expression also. So, but I know that my error 400 will start with something like error 400. So I just look for this word. So I have to figure out something, so I know what I have to figure out, and based off that I have to figure out कि क्या मैं structure दे सकता हूँ basically, or what I have to basically look for.
I'm getting you. I'm just trying to see the.
Basically, Mahesh, it is being used for most of the data analytics, right? Like एक user क्या कर रहा है site पे आके, so to figure out from a log, a bunch of logs that has been collected over the time. So these programs will be helpful. Like based on a user, like what he has done, all list out, so they can get those kind of things, and it will be easy for them to do data analytics and set up the for example, like in Amazon case, like what are the things I'm buying. So over a month logs, they'll search with my name, and based on my things, they can give me offers like what will be the other things which I might be interested.
नहीं समझ रहा है मुझे. I am getting what it is. Okay.
Only thing is like it is file processing, so it will be always faster.
It's always on the file, so you are reading the data from the file system.
Yeah.
And actually, like one thing I wanted to ask you is like I understand, like you said, like already like there is like conversions happening from Oracle, like if needed, like for to do any analytics. So similarly, whatever transactions I've done, and like say for example, like in Amazon, so all those things, log files will be located somewhere, and then you run this job on top of those files, correct, and get the output based on them.
Practically, you are not using Hadoop just to look at your log file. Practically, Hadoop is an ecosystem which is created for you to get the data from different sources, not only structured data and unstructured data and number of things. Then you merge and marry the data, do ETL on top of that data, and then you come up with analytics. Analytics cannot be come up. यहाँ पे मेरे को पता लग गया कि user मेरे इस URL से जा रहे हैं, but that will not make sense कि वहाँ से क्यों जा रहे हैं. यहाँ पे 404 error आ रहा है, मतलब user यहाँ से भाग रहे हैं, मतलब यहाँ से मेरा bounce rate बढ़ रही है. But that is not a solution to me as a business users. I want to know कि why this URL is giving now 400 error. Why people are bouncing out from this URL. So that you can figure out only if you get the different data also. Now if you get the data of the user also, and you get the data of his whole workflow also, if you get the data of the web server logs also, and then you merge and marry all these things, then only you will figure out the practical business reason why the users are basically running out of this URL.
Okay.
So the beauty is not only this thing ki you can run out that thing on a single file. The beauty is you can get your all data into a single place, a data lake, and on that data lake you can run your OLTP things. Not only OLAP, OLTP also. Oh, sorry, not only OLTP, the overlap also.
Okay.
So this is the thing which happens basically in sorted subsurface, which basically gets your data to the reducer part. So this is happening at the backend transparently to you, but just try to understand what is happening. That will give you again further insights what is happening in the system. So this is your input split, which is associated to a single mapper. Mapper reads the data from that input split, record by record. So that data, so the output of the mapper is dumped locally on that disk to a buffer memory. And as soon as the buffer memory reaches a particular limit, the data is dumped onto the local disk, not to SDFS. I'll ask you a question why. Till the time you can think of what is the reason that's not dumped to SDFS.
No, what is that?
Okay. So the input split is read record by record to the mapper. The mapper keep on emitting the data. Each mapper function emit the data, what we seen in the previous example. And similarly, there are other mappers also running up which are emitting the data. So this data is stored into local buffer memory of that disk or that data node. And once the disk is filled to a particular limit, the data is dumped onto the local disk of that data node, not onto SDFS. So I'll ask you a question why that's not dumped to SDFS, why it's dumped to a local disk. And when the data is basically dumped on the local disk from this buffer memory, that data is partitioned, sorted, and then only is filled to the disk. So partition based on the reducers, which one partition will be going to one reducer, and sorted, each partition is sorted. So this is where sorting happens, and the data is partitioned for each reducer, and similar thing is happening on the other data nodes as well. And at the end, when the mapper is all done, so by default this limit is 0.8 of the total memory size. There is a default configuration. And when everything is done, this data is merged together. So each partition is merged together practically, and as all the partitions are sorted, the merging is pretty fast. So now we have the partitions, and each partition is now intended for one reducer. And similarly, the same partitions are there for that reducer on the other mappers. So those partitions reaches your reducer, and similarly these partitions are going to other reducers. On the reducer side, these partitions which are coming out of different mappers are sorted because these were sorted over here. So the merging of them is not a great task. And the last two partitions are practically not merged, but they are basically practically just given an input to the reducer, and while input there they are merged on the fly to reduce one flow basically. And then reducer gets that sorted and the list of arrays how you see over there. So this is what happens at the backend on the short and suffer case.
Can you repeat that?
Repeat it? Okay.
Yeah, it's a bit fast.
Okay. So there's something called input split, which reads your data, and there's an input file format and other things associated over here, which basically practically reading the data from your input split. Record by record. For each record, your mapper map function is called. Each time the mapper map function is called, it basically emits the data as an output, right? So that data need to be stored somewhere. So that data is locally till the time whole mapper is done. So that data is locally stored onto the local buffer memory in the data node. But this buffer memory also has a limit. If you are reading a split of 1 GB or based on a split configuration and things like that, or you're emitting the data which cannot be fit into the buffer memory because buffer memory is not big enough. So that data is spilled onto the local disk of the mapper. And while that data is spilled onto the local disk of the mapper, before spilling it out, that data is basically partitioned, and the partitioning happens based on the number of reducers which will be created for this application or for this job. So data is partitioned based on the hash values of the hash codes of the keys. They are bucketed into partitions, and each partition is now intended for the for one reducer. So the job tracker knows how many number of reducers will be created for this job. So it knows which, and it also knows which basically reducer will be handling the the range of keys. So based on that, these things are partitioned, and each partition is intended for your each reducer. And these partitions are not only partitioned, but they are sorted also while they are before they are spilled onto disk. As they are sorted later on, merging these partitions is each partition is very easy because the data is sorted. And at the end, when the mapper is all done, all these partitions are basically sorry, each party. So all these individual partitions which are intended for reducer 1 are merged, all these partitions which are intended for reducer 2 are merged, and so on. And we get this big file where this is for reducer 1 and reducer 2 and so on. So the data which was intended for reducer 1 reaches the reducer 1, the data which was intended for reducer 2 reaches reducer 2, and so on. And similarly from the other mappers, the data which was intended for reducer 1 reaches the reducer 1. So this is a reducer 1. On the reducer, the partitions or the data from different mappers reaches up, and this data is sorted because we sorted it over there. So merging them is again an easier task. And this is how your reducer gets your key and the pair of values. And it's ensured that a key which is being processed by this reducer, all the values related to that key reaches this reducer.
Yep. Okay.
Getting Suraj?
Yep. What is that 0.8? Can you just explain one more time? Like the 0.8 is the percentage of?
Pointed is the buffer memory is say 25 MB. So it spills up if it's filled to 20 MB.
So it is the
0.8%.
percent.
Yeah, percent.
Okay.
Right. So now my question is, why it is spilled to the local disk, not to SDFS?
HDFS or to the reducer?
Here it spills this data, stores this data onto the local disk. My question is, why it is spilled to the local disk, not to SDFS?
I can only guess for the speed.
Yeah, that is what I was also.
Speed, but the thing is, if the mapper fails, then the mapper is again triggered on some other data. So we don't require this data to be persistent. Second thing is definitely the speed, because there's a lot of overhead which is required to copy this data to SDFS, because the 3 copies need to be maintained up, which does not make sense because data is pretty short lifespan.
We could not hear you last.
Like, way too far.
Oh, so what I was saying is there are two things. One is if we basically lose this data, does that affect our application, or does that affect our processing? The answer is no, because even if we lose this data or the mapper dies down, the job tracker will ensure that on the same block the mapper is triggered on some other data node. So we don't want this data to be persistent, or we are good enough even if we lose this data. Secondly, there's an overhead to copy this data to SDFS, because the 3 copies then need to be triggered created at the backend for you. So that is unnecessary process, and we are unnecessarily transferring this data to 3 data nodes, which does not make sense to us because we have to locally process the data on the reducer. So that's the reason.
Yeah, I think more than persistence, this saving on the 3 copies, I think will give more benefit.
That is a major reason.
Yeah, and actually, like one more thing is like once the locally they have partitioned, sorted, and spilled on the disk. Once everything is done for the reducers, like as many as reducers as required for the job. After that, like the process, like the bigger circle that you've drawn, after that it gets copied to the HDFS.
No, it's not copied to reducer. It's transferred over the network to the reducer node, and the data node which is running the reducer.
Okay. So like, and the entire shuffle and sort doesn't happen on the SDFS.
Nothing is copied over here to SDFS.
Okay.
This is all local.
Okay.
So this is what I said. Okay, some advanced features of map and reduce. Again, just understand the concepts. These will make sense to you again when you're looking at Pig and Hive. So now the question is, the benefit of Hadoop is we are processing the data locally, but you can see the data is transferred over the network to the reducer node. So what is processed out of the mapper? If you are sending the whole data to the reducer, again you might be transferring the petabytes of the data to the reducer nodes, and but technically that data is transferred over the network, so that might slow down your processes. So what we can do? So we'll come to the partition in a minute. Before that, let's look at the combiner part. So what we can do is we can use the combiner. What combiner does is it calls your reducer function locally on the mapper node. So for example, the word count example, if there were 200 apples which are available in the input split 1 which was processed on the data node 1, practically we are transferring 200 apple comma 1 from the mapper node to the reducer node. But we could have saved this 200 apple comma 1 transfer over to the reducer to one thing if you would have transferred apple comma 200. And similarly from 10 and 10 other data nodes where this was processed, rather than transferring apple comma 1 200 times from other different data nodes also, we could have transferred apple comma 200 from data node 1 and apple comma 201 from 200 data node 2 and apple comma 50 from data node 3. So what we can do for that thing is we can create a combiner, and the combiner will run on the mapper node only. It will basically combine your data before sending it to the reducer part. So in 99.9% of the cases, your combiner code is nothing but a reducer code, because that is running a reducer code locally on the mapper node before the data is sent to the reducer. So you can directly use the reducer class as a combiner class, and you can just configure that thing in your job tracker, job configuration basically, and trigger that thing. But beware of the things like if you have to find out mean, or if you have to find out
if you have to find out the mean or average,
average
it will work, but
mean,
mode,
mean it will not work. Mean or mode, yeah. Mean or mode kind of things you can't do this.
Or maybe number, or yeah, means mode.
Mode, yeah. Mean or mode kind of thing you can't do it. Otherwise, and that's why I'm saying in 99% of the cases you can do directly use the reducer class, but there would be few cases based on your criteria that might not work.
Would use of combiners have any effect on how many reducers are chosen?
No, not the reducer, but the data transfer over the network drastically reduces, so you can see the better performance.
No, I understand, but because now reducer has to do much less work.
No, reducer.
It does have less work, right?
Okay. So basically, the reducers are split based on the data sizes and other things. Otherwise, you can configure the number of reducers which you want to trigger in the application. You can just set in the job conf job.set num.reducer, and you can set it to 1 or 100 or 500. So over here in the configuration part, I can just set over here job.set number reduce task, and I can set it to say 10. So in this case, it will ensure 10 reducers are created up, and some of the reducer might not be doing nothing also if my data size is very small. That could also happen, but the 10 files will be created in the output directory. Some files might be empty also if those reducers do not get any data.
No, that is if you configure the number of reducers.
Yes.
If you leave it to the default,
so it will take care of practically transferring the data based on the data which is getting read. It will just figure out how many reducers are required, and it will try to equally divide the data to those things.
Yeah. So that's what I'm saying. That same data, same input data, Okay, you let Hadoop decide the number of reducers, but in one case
Actually,
you use combiners, and in other case you don't use combiners. Would you
yes.
have the same number of reducers?
Yes. And what I'm saying is, although I'm not 100% confident about the answer, but what I can say, why I'm saying yes is because the number of reducers are not figured out when your mapper code is done. Those has to be figured out before your mapper basically runs, because the short and shuffle phase spills out the data, partition your data, and the partitioning has to be done based on the number of reducers which are required in the application. So the number of reducers are defined prior data is really processed up, and that is defined based on your input displays and other thing. So even if you use the combiner, your data transfer of the network is less, but the number of reducers is decided much prior before your combiner runs.
Mm. Yeah. Okay.
Okay. Partitioners. So till now we were seeing that the number of reducers are getting created, and our data is transferred over to different reducers based on the uh, hash code of the key. But now my criteria is I want myself need to configure which kind of data need to reach which reducer. So in that case, you can create your own partitioners and you can configure them and you can use them. So let's look at a pretty interesting problem statement, and then it will make sense to you why you want to do this. So somewhere can you see the partitioners? Partitioners. Okay, so let me open the input file first. So this is my input file, which is where I have the player, age of the player, his gender, male or female, and the score which he or she has achieved in the sports, the game which has happened. So very small, very small file, and pretty simple data. Name of the player, his or her age, his or her gender, and the score which he or she has achieved in the game. My problem statement is little complex. I want to figure out max score for each gender in a given age groups. I have to figure out max score for each gender in a given age group. So less than 20. So for users or players who are less than 20, practically I am trying to be being fair over here. I have to give the gold medals to the players, and I can't give the gold medal to a 30-year-old guy and compare that person to 10-year-old guy. So I have created the age groups, and in each age group again I have to be a little bit more practical. I can't give a gold medal to basically I can't compare males and females together because their capabilities and other things are different. So I have to figure out the gold medalist in each age group and for each gender. So I have to figure out who is the best male scorer in the age group, who is the best female scorer in the each age group. So I can do it with the MapReduce, normal MapReduce, but I have to do some hacks, or I have to run my MapReduce code twice, I think. So output of the one MapReduce I have to take into other MapReduce, or I have to do something like that. So how we can achieve with the partitioner? So we have created an age-based partitioner. So before going to this age-based partition, let's look at a few other things. So in the mapper, what I'm doing is I know my data is splitted by tab, so I'm just doing it by /tab and doing those kind of things. But what I'm practically doing is I am creating a key as my gender. My gender is my key, and name, age, and score. tab separated is my value name, age and score. Tab separated is my value emitted out of the mapper. Now, if this thing goes to a reducer based on male and female, all the age groups for a male will reach a reducer, and I have to do some if else on the reducer or something on the reducer to achieve this thing. So what I can do is on the I created a partitioner, and this partition will be taken will be basically will ensure that my data for each age group reaches a different reducer. So before that, what I did is I have configured the number of reducers to 3 in my application, because I have 3 different age groups where on which I want to do some processing. In my partitioner, what I did is I have returned the reducer, or basically returned the hash code based on the age. So I just check what is my age. I have just written 0, 1 or 2 kind of thing based on my age. So I've written 3 different hash codes based on my just based on the user age. So now this will ensure I've configured already the 3 reducers in my application, and I've returning 3 different hash codes. So this will ensure the data will go to each age group will go to different reducer. Which reducer I'm not worried about, but will go a different reducer. And the reducer where my data is going up, I'm pretty sure that the data which is coming up is coming for a given age group for which I want to process. And there I've also defined the key from the mapper is the gender. So my reducer function will get male and the corresponding name and score of all the maps in that given age group, and similarly for female. So my reduce function will be called twice only in this case, and on all the 3 reducers. And on the reducer part, I'm not doing anything great. I'm just figuring out what is the max for that given gender and just printing that out. Got it, or shall I repeat?
No, I'm okay till how do you get the max score? Means you will get now for a given means in the reducer you will get individual reducer will get data from specific age group, but what will come in is the key would be the gender and the remaining values in which how do you find a max? Which I got up to the point where it will reach the reducer. I didn't get how did you find the max?
Just a minute. So this is my data. Okay. Yeah. What it is, there's something called mapper phase. There's something called your partitioner, and there's something called your reducer. So I have configured 3 reducers. There's reducer 1, there's a reducer 2, and there's a reducer 3. Okay, I am not worried about number of partitions that will be created based on my input data.
Yeah.
From the mapper, I keep on reading row by row, and what I'm emitting is key and value pair is key is your gender. So I just wanted this data to be tab separated. ये एक्सेल भी ना कोई लो धक्का ना होता है चलो कोई ना so comma and then my value that is ls 2345 tab separated basically. I can figure out what is 23 and 45. Oh, let's write it somewhere else. And so on, right? With my key and value. On the partitioner, what I'm checking is I'm checking this thing, age, and based on that age, I'm returning 0, 1 or 2. So what I did is I returned 1 for 23, I returned 2 for 89, and similarly 38 I'll return 1, and 25 I'll return 1, and so on. And here I'll return 0. And each reducer is handling the bucket of hash code. So now the data need to be equally distributed. So as we are returning only 3 things, so 1 will be going over here, 0 might be going over here, and 2 might be going over here. So now all the ones will go to reducer 1 with the, and when they will reach reducer 1, we have only 2 kind of keys, male or female.
Correct.
So now does that make sense?
No, but I still don't get how max will go. So you'll get female.
Female. So what we'll get is, it's so pretty easy, na? Kuch nahi karna. What I'll get is female, comma, and array of
Correct.
this thing, comma, similar things, and comma similar thing basically.
Correct. Yeah.
And इसके ऊपर for loop लगा के max निकालना है बस.
Oh, okay. Now that is what I was not sure how you calculate the max out. Okay, so you can process the array and find the max. Okay.
Yeah.
So
So we are just doing a for loop and figuring out max and just printing out the post. So if I run this, there will be 3 files which we created up for each reducer, and each file will have only data for a given age group. So if we run it, let me delete the output directly.
Miraj?
Yeah.
Can you just go to the Excel one?
Okay, just a minute. Let me run it so that it will run at the backend. Yeah.
Just can you explain me about the partition one more time, the 0, 1, 2 value?
So what I'm doing is in the partition, what I'm doing is, so basically partition is used to partition your data. If you remember the short and shuffle phase. Short and shuffle phase, so this partition is basically used to partition your data. And each partition is intended for a reducer. So this partition is basically used to partition your data. So here what I'm doing is I am partitioning my data based on the hash code which I am returning over here. So what I'm enjoying is for a given age group. So these are the three hash codes which I'm returning up. So for age less than 20, I'm returning a hash code, basically a constant hash code of 0. For age between 20 to 50, I'm returning a hash code of 1% number of reducers will practically give 2, and 2% number of reducers will practically give 1.
Yeah, got it, yes.
So it's running up. Oh, I did a cat. So see 3 files, and if I open any one of them, I'm opening the second one.
All these examples are there in your
yes. So see only for so the one age group and the corresponding maximum. So all these examples are there. All this data is also shared with you. So as I shown you, the examples are there, and inside code there is a folder called data. So all this data is also lying over there.
Yeah, because we would like to look at it at
access logs I showed you, partition I showed you. So all this data is also lying over there. So you have to just put the data into your SDFS and run it.
Correct.
And how to run it is also, again, how to run it, you don't have to worry about, just copy this command. And this jar file is again lying with you inside the code and MapReduce. This is a jar file.
Yeah. No,
So that,
more than running, I wanted to see actually the code.
yeah,
So that's
code
good.
is again.
That's good.
So if some of the files
Yeah.
might be missing in the non-Maven project because I don't work on non-Maven project. So, but all the Java files would be available in the Maven project. So all the latest code,
Oh,
because I normally work on the Maven project, so I keep on dumping this thing to over there. So non-Maven, I really work. I just created it for people who really do not want Java. So then I really do not update it also, because the people who don't want Java don't look at it.
it's not question of whether we don't want.
Yeah, but you might be requiring it later on, or you have to figure out. The code is all shared with you.
Yeah, no, nice.
So, so this is what I shown to you, partitions, right?
Yeah.
Compression, reproducer, this is okay. Okay. So compression, I'll talk about in the compression. I think if we have time, we can start a new topic, or compression. Will I talk about that part? So, but to just give you a short glimpse, the compression is supported at all the three phases. That is, your data lying into HDFS, the data emitted out of the mapper, and the data emitted out of the reducer. So practically going on to HDFS. So because you can compress your data at all the three phases. So this
For that, you can define the algorithm for that.
yes. We can choose what compression we want. So there's 4 native compressions which are supported in Hadoop world. I'll talk about those compressions, the benefits and the disadvantage of them. So we'll talk about that thing in the compression separate topic totally.
Okay.
But these are 3 phases where you can apply the compression, and I hope you can understand if we apply the compression, what are the benefits and disadvantages. I'll talk again about that thing in the compression today. Zero reducer practically you might not be using, but you can just define the number of reducer to 0. So in that case, the output of the mapper will be your outputted to your SDFS. Like in okay, I'll tell you in a scoop part.
No,
And
but can I ask you, if you have zero reducers, the shuffle and sort will still happen, right?
the sorting will happen. Yeah. So in that case, ना अभी जो फाइलें बनती है ना, ये जो फाइलें बन रही है R1 R0 instead of R it will be M. So each mapper one file.
Correct.
And sorted.
Yeah, but mapper के बाद it is
reducer होगा नहीं ना कुछ. There is no reducer. So mapper output is emitted to SDFS.
Yeah, but then is it going to sort?
Yeah, sorted. So data is sorted. The data emitted out in this file is sorted based on the key.
Oh, okay.
But two different file में data वो तो sorted हो नहीं सकता, वो तो अपनी अलग-अलग file है.
नहीं बराबर है. But if you go back to your this thing, where it said no sorting required by the jobs. That's why I was kind of confused.
But data, the mapper output, so this half of the sorting is half of the short and simple phase basically runs. So, yeah. So half of this thing runs. Till here it runs. इतना तो चलता है. But a partition नहीं होगा, reducers नहीं है. So only single partition.
But like yes, single partition. But like the one which you highlighted right now, those are reducers, right? R1, R2, and R3.
So this is your map. This is your mapper. So this data is split to HDFS.
So you could have files. You will have files per mapper, but in each mapper output file, you could have data which actually would have gone to one reducer, but which will not. So you may have data duplication of some data in individual mapper.
Input data, you are doing some processing on the input data, some rare case which you want to just process out.
No, I understand, but just output may theoretically you could have same key value available in different files for different mappers.
Yeah, if that is the input data, yeah, definitely it will come out of that mapper output.
Yeah, okay.
And distributed file cache. Let's say I'm running a Java code where the Java code might be referring to some other jars which are not there in the Hadoop, or let's say I'm running some code which might require to access some static data which is reference data for my data to process or similar things. So in that scenario, that data might not be available, or that those R's might not be available into the data node environment where your mapper reducer code is running up. So in such a scenario, you can use a distributed cache. So what distributed cache will do is, it will ensure the data or the files which you are adding into distributed cache is available locally on that data node where your mapper reducer is running up, so that you can just refer them locally over there, something like this. So distribute cache, and this is basically useful if you have some static data which need to be referred up, or um, like some you have to set some environment, like you're running Python. So we'll talk about Hadoop streaming. So you can write your mapper and reducer not only in Java but in some other languages like Python, scripting languages like Python, Ruby, R, things like that. So that Python might be referring some Python environments, R, or things like that. So those things you can add it to this distributed file cache, and that will be available locally on that corresponding data. So Hadoop streaming is basically a way where you, instead of writing a mapper and reducer code in Java, you can write your mapper and reducer code in any of the scripting languages, which can just interact with I/O of the which can basically read the data from the I/O and output the data to the output. Basically, input and output files which can read and write to input and output files. You can use any of those scripting languages to write your mapper and reducer code, not only in Java.
Mm.
So, any questions, anything which you want to ask?
No. I keep on asking a lot of questions anyway.
Sure. Okay. So, do you want to continue, or do you want to go to tomorrow, the new topic? Or we can,
How much it will take,
okay,
the
we
new
can.
topic?
I think the compression and the file formats will take around half an hour, or we can look at the compression part and then we can look at the file formats tomorrow. Okay.
Yeah, that would be good. So
So let's take we can take a 5 minutes break and then we can come back.
Okay.
Yep. Oh. Hi, I'm back.
Yeah, I'm back too.
Just wait for Mahesh.
Yeah, I'm back. I'm back. Can you hear me?
Yep.
Okay. All right.
Hi. Back everyone?
Yes.
Mahesh?
Oh yeah, I'm there. I said I'm back a while
Oh,
ago.
oh okay. So, sure. So I started playing with my daughter. She just waked up.
It's a morning for her.
Yeah. So,
Is she school going or still very
she
young?
just 4 months.
Oh, then obviously, hopefully you get to sleep in the night.
Yeah. Now I hope. Previously she used to wake up, but now she's adjusted.
Okay. All right.
Okay. So, right. So as I told you, we can do a compression at three different layers. That is input files, mapper output, and the reducer output. So before going ahead, I would like you to think out loud. What do you think would be benefit and disadvantages of compressing the data in different phases?
Benefit is obviously that you will reduce the network traffic. So obviously you are going to have less data going across the network. So things will be faster because of that. Secondly, compressing will also give you some level, I'll not say a lot, but some level of encryption. Uh, and on the disadvantage side, obviously, moment you're compressing, on the source side you spend overhead in compressing the data, and on the target side you spend time in decompressing the data. So that will compensate for the network traffic.
Mm,
So you have to see which one is better depending on the amount, and considering the large amount of data, compression may be good in case you have got tons of data to be sent across.
It's not only the network, but you definitely drastically reduce your IO because now you're routing lesser data and doing processing on that. So if I have a 1 GB file and I have to if I use a normal compression of text file, the compression can get you to 80%, 70%. So I'm just eating 200 MB of the data and the IO is drastically reduced. So that reduces the most time taking or the most time consuming part of the whole process, that is IO. However, the CPU time required to unprocess it is a separate case. So you will be definitely requiring more CPU cycles to uncompress it, but you drastically reduce the IO also. And similarly for the output from the reducer. So yeah. So yeah, definitely it reduces the data which you have to read from the disk if you compress the input files. The time, the less disk uses. So again, although we are using the commodity hardware, but when you are storing enormous amount of data, you definitely have to buy more data whatsoever you are using, private clouds or Amazon AWS or public clouds. So definitely you have to pay a cost for the disk. So you will keep on getting pressures from the management team if your cost is high of the cluster. So you have to compress your data. So we also did a lot of compressions to reduce the cost of the whole cluster, and not only that benefited our other processing, that reduced our processing time also, but that was the first criteria for us was to reduce the cost. And then I'll tell you, at different places it's always suggested to use compression because that drastically reduces not only your this cost but that also increases your processing power. Basically, that reduces the processing time of the whole job. So increase CPU users definitely. Decompressed automatically as they are the native decompressed, and so time is reduced to read the data. So a default codec which is used is ZZIP codec, but there are others also. I'll talk about it. So compressing the output file format, you are definitely writing less data onto the SDFS. So the data management and the block management, everything is fast. So this is how you can set the file output format of set compression, job output true, and what compression you want to use. So here I am using the ZZIP again in this example. And the third place is the map output. That is the output from the map class, the data which is going to the reducer. So here we can definitely reduce the network transfer over the data because the data which we are sending up is less and the data is compressed. However, the compression and decompression has to be happen in the same job. So that might require more CPU and that might require some time, but definitely this reduces the network data which is transferring over the network. So in this stage, the suggested things are LZ and Snappy. I'll talk about all those things in some time. And this is how you can compress the data of the mapper output. So you can just set it the mapper compress mapper output 2 and the codec which you want to use for compression. So here I am using ZZIP again. Okay, so this is how you can do a compression at the different levels. If you want to do a compression at a record level or basically block level, and what compression you want to use, like the way here you use the ZZIP. So what compression you want to use, and is the compression enabled or not on the mapper list or the data which is emitted on the mapper basically. Okay, so these are the compression, different compression which are really used in this word. There are others also, but these are highly used. So this is an interesting thing. The algorithm which is used for this compression is ZZIP, BZZIP2, LZ1, and Snappy. ZZIP and BZZIP give you pretty high compression. They give you 70 to 80% on text files kind of compression. If they are giving me high compression, definitely they are slower because the CPU is required more for them to compress and decompress. So the compression and decompression are slower as compared to LZ1 and Snappy. However, LZ1 and Snappy do not give me high compression. They give you 30-40% kind of compression, but they are fast because they are not compressing the file much. But the interesting fact over here is this thing. Is splittable. If these compressed files are really splittable or not. So can you think of, so this is your input, this is your mapper output, and this is your output that is again produced out of the reducer to your SDFS. So can you think of on which phase you could be applying which compression, or which you think would be better, which compression would be better in which phase or which phases?
So we can, like, I believe, like, on input we can only do bzip2 or lzo
BZ2
because
or LZO, okay.
and because that's the input file. So when we send it to the mapper, they should be able to read that.
Sorry?
Because the input is like input to the mapper, right? The data to the mapper. So the
Mm-hmm.
mapper to read based on the different formats we have input format. So they should be able to do the split and then they should be able to get the data what is really needed. So for input file, I believe it will be zip2 or LZO.
Uh-huh.
Or mapper. Or for mapper, like all four can be possible. All four should be good.
Mhm.
I think on input file, I believe these two restrictions are there.
Okay. Okay. So few things which you have to take care. The first thing is when you're reading the data, first thing which you have to reduce is your IO, because that is the most time consuming thing. You have to reduce the IO. These are the two suggested things which you should be using. That is now hard and fast rule. It's all based upon you. But these what I'm talking about, the suggested things. So these are the two suggested things which you can use for compressing your input data or the output data. And when your data is transferring over the network, again, at that time you have to compress and decompress the data from the mapper side and to the reducer side, and then the short and suffer phase, there's a lot of other things which happened, which I shown to you. So we don't want to waste the time on the compression and decompression also. So, and we want that thing to be a little faster. So people suggest Algorithm and Snappy in this case. Now, if the file is not splittable, does it not make sense to have that into SDFS? Yes. How we can use this unsplittable ZZ with the help of different file formats to make it splittable? I will talk about that part in file formats.
Okay.
But on when you are reading the data, if it record or a particular record is split between two blocks and it is gzip format compression,
Mhm.
the mapper is not going to get the good
Yes,
data,
yes,
right?
yes, yes, that's what I'm saying. But with the help of different file formats, I'll tell you how you can use ZZip also to achieve a splittable file.
Oh, okay. Okay.
And practically, when you're splitting your data into SDFS, you have to store your data as small as possible, because that will not only store reduce your IO, that will reduce your cost of the cluster also. So just by enabling different compressions on the systems, we were able to really achieve good reduce the processing time of our whole jobs by around 15-20%. So you have to really try out the different file formats combination of for your data, what you want to achieve out of your data, and the compressions. So you have to do hidden trials also, because there's no hard and fast rules and kind of things. But if you understand these are the compressions and the file formats, then only you'll be able to do those hidden trials based on looking at the UI, which part. So on the UI, you can look at how much time mapper took, how much time reducer took, and things like that. So you can figure out where your time is going up, and you can try to think of if you have to do card, you choose different compression on different file format. So as I told, ZZip and BZZip2 are compress your data highly, but definitely in that case they require more processing power. So their processing compression and decompression are a little slower. So that is what I'm saying over here. And few other facts. So few other comparisons, like BZZip2 decompression speed is faster than its compression speed, but it's slower than other formats. So few other facts. These are just the facts. But in practice, what you have to know is the BZZip and ZZip2 gives a pretty good compression. However, their decompression, the compression speeds are slower as compared to LZO and Snappy. So LZO is extendable if the file is indexed, and Snappy is from Google. So there are few other facts which are comparing Snappy and LZO on compression and decompression over here. But okay, so this is an example where we are using the compression. So this is an example of Hadoop streaming, where we have not created any Java code, but we are using Unix program to as a mapper and reducer. So we'll talk about the Hadoop streaming sometime. So okay, anything which you want to ask?
Yeah, one question.
Yeah.
So this compression, now gzip is something which is nothing unique to Hadoop,
Yeah,
right?
yeah,
It can
definitely.
be outside Hadoop also. So now if I am copying data from my local file system to HDFS, can
Mhm.
I compress on the fly?
If
Or
you
do I have to copy the data either compress outside HDFS and copy to
While
HDFS, or
copying, there's nothing such command which will compress and then copy.
can you not pipe?
Yeah, pipe वो तो क्या करते हो? Direct command नहीं है, pipe तो that's different. Pipe करके तो you can do it. Yeah.
Okay, no, the reason why I asked that question is because if I had to copy that file to HDFS and then compress it, then anyway I'm going to require that kind of disk space, right? Double, practically.
So reads and yeah, definitely. Then you. So it's all about you. How do you want to define your ETL basically?
Mm, mm.
So, and the default compression again in this word is again ZZip. So if you don't define the compression codec, the default one is taken as ZZip only.
Yeah, no, why I was asking that question is because most of the data source for my Hadoop HDFS is going to be outside HDFS, right?
Yes.
In either a database or in some other sources, which are really not in compressed format. But if my interest is when I go to HDFS, it should be always compressed data.
Yes.
Then there should be a way by which I do it while the data is being written to
So
HDFS rather than.
when we look at the scoop and sort of thing, so there you can define so while your data is read from RDBMS word, it will compress your data while before placing it to SDFS.
Okay.
So then we have file formats. So file formats we can discuss tomorrow. It will take time to discuss all the file formats. So
that's fine. Tomorrow is fine.
We can meet the same time
anyway,
tomorrow.
Yeah, I'm okay with that. What about Suraj?
The same time, 9 o'clock, right?
Yeah, same time.
Yeah, 9 o'clock, I'm fine.
So,
So one question though, like that means like on Saturday weekends we don't have any classes?
Yeah, this weekend no class.
Okay.
So to make it a little faster, we can have again a class over the next weekday. So we can discuss it.
Oh no problem. I'm fine.
Yeah, I'm okay with weekday classes. Okay, no problem. And weekend is also fine, but weekend is not a problem. Weekday is also not a problem for me if I don't have.
It's just very small batch this time, so we can adjust it ourselves.
Yeah. Okay. So tomorrow we can decide about the dates for the next week, right?
Yeah, we can discuss about the next week. Yeah. Tomorrow we can discuss.
Or otherwise we can decide now.
Yeah, I think the same day would be fine for me. Same days.
Is it okay with you, Suraj?
Yeah. I'm fine.
So let's do it next Tuesday, Wednesday also.
Yeah, next Tuesday and Wednesday. This Saturday, Sunday, no class.
Yeah, this Saturday, Sunday, no class. Next Tuesday, Wednesday, we'll do it and then decide what to do.
Yeah. Okay. So now I have to call my folks and say that I'm available for this weekend.
I also have to do that because
I've dropped the email. Didn't you? I've dropped the email that.
Yes.
Yes. No, got it. Yeah, but I got the email. So that's good. Yeah,
but actually, we already told them that like we are busy, we are having some classes, so we can't come.
Okay.
My sons are happy that I can spend some time with them.
Oh, that's your son.
Yeah, and they are grown up. They are not small. They are grown up.
Okay. I think they are in high school.
Pardon me?
They are in high school, right?
Who's my sons?
Yeah.
Thanks for. I may be sounding a bit young, but no. My elder son works for Google.
Oh.
And and my younger son is just about to start working. So, so my younger son is 22 years old. So no, I got grown-up sons. So, but we still spend time together.
So so Google is the creator for GFS and all that only SDFS created. So you can.
He's actually working on Google Wallet. So he's
Google Wallet.
He's a Java developer. So, but of course I don't know Java. He knows.
Okay. Sure. But there is a huge demand for this time. The big data and Hadoop is high demand in US.
Yeah, that's what I want to just add, because I work at architecture level, so more
Yeah,
from
definitely.
that point of view, I'm looking at it not from coding point of view, but
Yes.
yeah.
So definitely, it
Good.
will definitely advantage you to think of what system you want to use, or watch what.
Correct. All right. So talk to you tomorrow.
Okay.
All right.
Yeah,
Thank you.
See you. Bye bye. Have a nice. Good night.
Bye. Bye. You will add this
Yeah, PPT. Yes,
also to
Yes,
the
yes, yes. I'll add it.
PPT, right?
Yeah.
Okay.